I'm going to start with just some basic definitions on this. And what we're going to do is we do what we call marginal analysis. So what the word marginal in business means is you're talking about how something's changing. So you're dealing with a rate of change. So you could have a total cost function. We've already looked at that a little bit. Well, if I want you to find a marginal cost, what you're doing is you're looking at how the cost is changing over time, okay, as you produce different amounts of items. So that just means take the first derivative. Same thing with revenue. That's the amount of money that you're bringing in, not worried about costs. Marginal revenue is the first derivative, okay? And then profit, if you don't know this is logical. How does a business figure out its profit? Well, they take the revenue, that's all the money they're bringing in from whatever they're selling, and then what do? You take off the cost of producing things. So that profit is going to be always revenue minus cost. If you want to find marginal profit, then you're doing a derivative. So the idea is marginal. That word just means we're looking at a rate of change. Therefore, we're looking at a derivative, okay? That's the idea. And a lot of times we're interested in how things are changing, okay? So the first thing I want to kind of look at here is, this is kind of important right here. If you have a cost function that's represented by C of X, C of 20, if I say C of 20, that is not just you want to make sure you understand that does not mean the cost of just producing the 20th item. It means the cost of the first 20 items, okay? And so forth. If I say C of 50, that's not just the 50th item, it's the first 50. You want to make sure you understand that real clearly. So what we want to kind of look at is this formula right here. We're going to deal with this. So if you want to find the exact cost of just one item, okay, then what you would do is you would take that item and you would subtract the previous like this. So you can write this down if you want to as an example. This would be a good thing to write down. So if you wanted to find the exact cost of, say, the 100th item, okay, that you're producing, okay, that is not C of 100. What it is what you're doing is you're doing C of 100 minus C of 99 like that, okay? So you want to wrap your head around that, make sure you understand that, because what is C of 100? What did I say that was? That's the cost of all 100 items, right? And then what's the cost of C of 99? That's the cost of the first 99. So if you subtract, that would give you the cost of that 100th item. Does that make sense to everybody? Okay, so you got to understand how this cost function works, okay? All right, so we're going to work a little bit with this. So in this example, we're going to do a little bit with this. First thing is you're given a cost function. Cost functions can be all types of functions. This one is a quadratic that's upside down, so it's going to be changing at all times. So what this is this is your manufacturing automatic transmissions. This is a total weekly cost, okay? So if you want to find the marginal cost, what do? You take the derivative, okay? A marginal cost is a rate of change, so you want to go ahead and do your derivative, okay? All right, what's the derivative? 600 minus 1.5x, right? Okay, see, the derivative of the constant is 0. The derivative of the x term is the number in front. Then by the power rule, you're doing 2 times 0.75, which is 1.5, like that. So that would be a function. And what that does, as x changes, so does the rate of change on that. So the idea would be like if you were producing 50 items, then you could get an exact rate of change on that, okay? Now you want to understand what that rate of change means. Okay, so what we're going to do next here is find the marginal cost when we do 200 transmissions per week. So all that means is we're just taking the marginal cost function and we're evaluating the derivative. It's kind of like the velocity at a certain time. It's the same concept. So you just do 600 minus 1.5 times 200. You can use your calculator on this if you want to. So that's 1.5 times 200. Should be 300, shouldn't it? So that's 600 minus 300. So that would be 300 like this. And if you read the problem, it says that's dollars. That's a weekly cost, so it's in dollars. So this is just going to be $300 like that. That's what the meaning of that, of what that is. That's how you find a marginal cost like that. So what this is saying now is this. Remember, this is a slope of a tangent line. So what this is saying is this. One thing that you want to do is you want to understand what this stuff means. I mean, it's easy to find a marginal cost and evaluate it, but a slope is a rise over run. And you want to think of it this way. So if I'm telling you what this means, it's a slope of a tangent line. Well, what does the rise mean? The rise means that $300 is changing. The run is X, so that would mean like the number of things that you're producing. So you would say at a production level of 200 transmissions per week, the cost is changing by, and it's increasing because it's positive, it's increasing by $300 per item. Okay, that's the idea. Okay, does that make sense? Okay, so that's what another thing that you're going to do is write interpretations of these things. Okay?
Say that one more time.
Okay, I'm getting ready to say that and have you write it down. Okay? The way to remember this now is, since we got 300, and it's a rise over a run like this. So one of the things I want you to be able to do is to clearly write what this means. And don't just say that that's the rate of change. Okay, that's not good enough. What you want to say is, first of all, at a production level, and remember that's important on this because you have a production level of, and it says 200 transmissions per week. Okay, you always want to kind of write that if you're writing an interpretation, okay, like that. Okay, then what it means is the cost is increasing. Now the reason I like you to say increasing is because it's positive. See, if that 300 was negative, that would mean you're at a point in time where the costs are declining, like that, okay? So we would say that it's increasing by $300 per week, like that. And then the idea is X is going to end up being just how many things you're producing, so it's going like that. All right. So it's a rate of change, and what you're going to find on this function is as this number changes, as the 200 changes to a different production level, then that cost is going to be changing at a different rate. Does that make any sense? Okay. So that's what we mean by marginal cost. Okay. Next thing we want to do is we want to find the exact value of the 201st transmission, okay? So what you do is you do this. So the exact cost, and you want to make sure you know how to do this, of the 201st. Now what that's talking about is only the production of that one transmission, the 201st one. What it's going to be is it's going to be C of 201, and then what do you got to do? You got to subtract something.
Minus C of 200.
There you go. Minus C of 200. Does that make sense to everybody? Okay. So what you got to do now? You got to go back to the cost function. So I'm going to just kind of write down this cost function. I'm going to make a little screenshot of this so you can kind of see what I'm doing here. So we need to work with this one. Now you can work with this on your calculator. You'll need to use your calculator to get all this stuff crunched out. So let me just kind of paste this over at the side. So we're going to take this cost function. We're not dealing with the marginal. We're dealing with exact cost. So what you're going to do is you're going to just do 50,000 plus 600. Then you're going to plug in the 201 like that, and then minus the 0.75 times 201 squared. Okay, that's going to give you the cost of all 201 transmissions. Then you got to subtract off the cost of the first 200. So you do kind of the same thing. 50,000 plus 600 times 200, and then minus 0.75 times 200 squared, like that. Okay. Now what you can do, you want to use your calculator on this, and with a good graphing calculator, there's a couple of things that I want to show you how to do. Now first of all, what I'm going to do is just do the first bracket first. So I'm going to do, just in one step, I'm going to do 50,000 and then plus 60.
600.
What's that?
600.
Is it 600?
Yeah.
Oh, it is 600. Thank you. Okay. So we have 600 and then times 201. Okay, then we're going to do minus 0.75, and then we got to do the 201 squared, like that. And so you just let your calculator crunch all the details out for you like that. So I'm going to write down what that is. That looks like 140,299.25, like that. So what that is that's the cost of all 201 transmissions. You can tell logically, there's no way one transmission is going to cost $140,000. That's a really high-tech transmission, right? So it's all 201 of them. Now what you do is you do the next one, same way, you do 50,000 and then minus the 600 times the 200, and then you do minus 0.75, and then parentheses, then you do the 200 squared like this, and then that'll give you the cost of the first 200. So if I've got everything plugged in right, that does not sound right. I don't think I did that right. I may have, though.
It's 140,000.
What did I do wrong? Oh, I put a minus 600 like that. Okay, let me do that again. Sometimes this calculator is so hard to see on here. Did you guys get it already?
Yeah.
Okay. Okay, let me just make sure. Okay, I am getting this. I'm getting 140,000. Does that look good? Okay, and then what you would do is just subtract those two numbers now. So that is giving $299.25 like that. Okay, so what that is that's the exact cost of producing that 201st transmission. Now the reason I want to do this is because there's an important relationship you guys want to look at. Look at the answer to part C. Okay, that was we did the marginal. This is the marginal cost. So this thing right here is the marginal cost of 200. Now look at the answer we got. What do you notice?
Pretty close.
They're pretty close, okay? You're going to find that a derivative is a good estimation of an exact cost. It's not perfect, but it's a good estimation. And the relationship between this you're going to find is this. And you want to write this down somewhere, maybe at the top or something. C prime of 200 is close. So I use that symbolism to show that it's approximately equal to the exact cost of the 201st item. Okay, like that. So it's actually a pretty good approximation. So you can do that, use that as an approximation tool. That's the reason I wanted to show you that then. Okay? All right. So the other thing that's kind of good to do on a problem like this is this. Now, I would recommend, like if you're doing homework and stuff, you want really to use your calculator on these things quite a bit. So graphing is also another good way to do that. And I'm going to go ahead and let you guys work on the next problem yourself. And it's just repeating what I did, and give you a few minutes to work on that and make sure you're okay. You'll definitely need your... Now, when I'm doing these problems, one of the things I'm going to do is save a little bit of time by graphing. I'm going to show you, while you were working the problems out, I was working on the graph a little bit. Okay, so first of all, part A, make sure you got the right derivative. That should have been 100 minus 0.5x. Okay, so that's your marginal cost function, taking the derivative, okay? And then we're going to do the marginal at 50 guitars per week. So we're going to do C prime of 50 So that would be 100 minus 0.5 times 50. That's 100 minus 25. So you should have got $75 for your marginal cost then. Okay? All right, so if you get your derivative okay, that's a fairly simple thing to do. Everybody okay so far? Okay. Now, what this means, you want to always write these interpretations in a pretty good way. So what you want to do is you want to say, like, at a production level. You need to have that in there, because if you don't say that, then it's really meaningless. So you got to say at a production level of, and let's see, this is, it just says, doesn't say per week or anything. So a production, does it? Oh, it does say per week, doesn't it? Okay. Production level of 50 guitars per week. Okay, now what does that mean? Now see, that is a slope. Okay, so it's a rise over run. So what's happening is it's increasing at $75 per week, like that. Okay, like that. That's the idea. So you would say at a production level of 50 guitars per week, we would say that the cost, and it's increasing because that's a positive number. So we'd say it's increasing $75 per week, like that. That's the idea.
Is it per week or?
No, per guitar,
Okay.
not per week, per guitar. I just caught myself on that. Okay, so every time you produce another guitar, then that cost is going up by $75. That's the idea. So that's the way I want you to write that then. Okay, so the next thing is find the exact cost of the 51st guitar. Okay, so what you do on this is you do this. You do C of 51, and then what do you do? Subtract C of 50, right? Okay. Now see, what I'm going to do is do this on my graphing calculator, and you can do this. This is the way I would do this, problems like this. Just trace at 51. I went ahead and just graphed this, okay? And I wrote up here what my window was. So what you've got is you've got an upside down parabola for your cost function. So if you trace at 51, what you guys should have got on that is, assuming I get everything in my calculator right, is $5,449.75. What does that mean? That's the cost of producing all 51 of the guitars. Okay. Then what you do is you trace at 50. So what you would get on this is 5,375. That's the cost of the first 50. And then you just subtract the two. Okay. All right, so what'd you guys get on that then?
54.
Okay, and was it fairly close to 75? Okay, that's kind of what I was wanting you to see on that, because generally you're going to be pretty close to that marginal cost when you do that then. Okay, so yeah, this is $74.75. Okay, so that's the exact cost of producing that 51st item like that. And again, I want you to see if those things are pretty close. Okay, so the idea, one other thing I do want you to write down on this is, again, C prime of 50 is close to C of 51 minus C of 50. Okay, so you're always, when you're looking at this marginal, that's going to be a close approximation of the exact cost of the next item. That's the idea. Okay, so you want to make sure that you know and understand that well.
Can we go to example 1C real quick?
Yeah, what'd you have?
No, example 1C, the one above.
Oh, the one above?
Keep it.
Okay.
So you wrote by the end $300 per week, but you meant $300 per transmission.
Transmission, yes. Okay, sorry about that. Now the production level is per week, but that's
No, the production level 200 transmissions per week. Cost is increasing by $300 per.
No, right here, right there. Okay, it should be transmission there, and it should be week above like that, because your production level is per week. Okay, like that. Okay, I didn't catch myself on that one. Okay, any questions about what we're doing so far? Yeah.
So for that third term, when we do 0.25 times 2, why is it times 2 and not like squared? Because I accidentally did squared for a second. Like
Now, which part are you talking
for B,
about?
well, I'm talking for both of them. I'm sorry, for part A. So when you're doing the second term, right, so it's 600 minus 1.5x because 1.5.
Oh, you're looking back at this example 1?
Just up on A though, like.
He's talking about the derivative.
Yeah.
Right here?
Yeah.
Oh, okay. Yeah, because what you're doing on the derivative, you know, that's 600, so you're multiplying. So you're writing down the constant, and then you're doing the derivative. The derivative of x squared is 2x. So you're multiplying 2 times 0.75, okay? It's kind of like this. The decimal may bother you a little bit, but if you had 3x squared, you're doing 6x.
Gotcha.
You bring the exponent down, multiply it by that constant, okay? Okay, now what I want to show you next here is kind of why this marginal, this graphical, I took this out of the book, and this is kind of a good way to show this then. So a marginal cost is a derivative, okay, that's what we learned, it's a rate of change. So basically what you would have is the definition of a derivative would be that, what I highlighted. So that's your difference quotient. So limit as h goes to 0, c of x plus h minus c of x over h, where h is some small positive number. This thing, we didn't talk about this before, but that delta x is really just a small change in x, so it would be a small change in production, okay, is what you're doing. So that's, those two things are given that. So you can write it that particular way if you want to. So what happens is, and I'm going to try to show you, this is something you want to try to wrap your head around. Sometimes this is kind of hard for students to do this, but I want to kind of go through what everything in this graph means. First of all, this is your cost function right here, okay, the one you can kind of see in the green there. And then that would be how many items you're producing. So C of X would be the cost of all X items. Okay, if that was 50, it would be the cost of all 50 items like we talked about. Okay, C of X plus 1, now that right there does not mean the cost of that item, it means the cost of all of those items, right? That's what I was talking about. So this graph is going to try to show you a couple of things. Delta X, I'm saying if delta X was 1. Okay, now that's kind of like the H. If we just made that go up to one more, producing one more item, then this thing from there to there is going to be 1 like this. Okay, well what you're going to find on this then is, the derivative, if you look at C prime of X, the derivative of X is going to be the slope of this tangent line right there. Okay, now what is a slope? A slope's a rise over a run. So if you look at this, right here, this is the part that you got to try to wrap your head around a little bit. I'm going to just sort of do this like this. This right here, you would have a rise over a run. So that rise would be some number. That's a rise. And that run, which would be right here, is going to be 1. Okay, because we're moving out one more production level like this. So what that means is if it's the rise over the run, if C prime of X is rise over run, and if the run is 1, then what you're going to have is you're just going to have it's equal to the rise. Okay, so if you look at this diagram right here, what they have here, see this little bracket right there? That's telling you what the rise is right there. That right there is the value of C prime of X. Okay, that is the slope of that tangent line. And it's that little piece because the run's 1. Does that make any sense?
And delta x is 1 because x plus 1 minus x?
Well, a delta, we're just letting it be 1 because we're talking about production of one more unit. So what I'm trying to do is show you why that C prime of X is an approximator for the exact cost of the next item. That's the idea. Yes?
I'm sorry, you said the rise over the run of that area is the value of C prime of X.
Yes, exactly. See, that's the tangent line. That's what C prime of X is. It's the tangent line of that function at X, and its rise over run. Well, the run's 1. Why? Because we said we want to produce one more item. So rise over run, so rise over 1 is rise. So that means in this particular problem, that piece right there is the rise. From there to there is the rise. You guys with me there? Okay? So that's what you get. Now, what that thing is close to is going to be c of x plus 1 minus c of x. So what you got to kind of see on this is this piece right here, they're real close to each other like this. Now I think I kind of did one thing I didn't quite do right. This right here is the rise. This whole thing from there to there, that's the rise like this. This little thing right here, that's going to be the exact cost like that. So they're very close to each other. So this distance from here to here is c bar of x, c prime of x. This right here is the cost of this item minus that. So if you subtract that minus that, if you subtract that y value minus that y value, you get this. Okay, that's the idea. That's a little hard, I think, for students sometimes to wrap their head around, but that distance there is the slope of the tangent line. Is that making sense? This thing right here is the cost, the exact cost of that item, because what is it? It's this y value minus that y value, therefore it's the distance from there to there.
So is that why the equal sign is, because it's just approximate?
Yeah, it's approximate, okay? And it depends on how the function is curving. Sometimes it's super close. If the function is kind of has a different type of curve, that will be off more. Okay, there's always going to be some sort of an error in there, but they're pretty close to each other. Okay, does that kind of make sense? Okay, all right. Those are kind of good things when you're studying this to wrap your head around, because you're going to use this quite a bit as an approximation. Okay, so that's what we kind of looked at, is the marginal cost is an approximator of the exact cost of the next item. And you might want to write of next item. That's kind of a good thing to put there. Okay, sometimes students kind of get that backwards. So the idea is, if I wanted you to use, and let's just write one more example like this. So if you had like c bar of 40, that would be approximately equal to what? C of 41 minus c of 40. You want to make sure you get that in the right order. Okay, so you're looking at how you approximate the cost of the next item, the exact cost of the next item. Okay. Okay, any questions with that? Okay. Okay, so let's look at a couple of things on here. Another example. This is a more specific example of what's going on with this particular function, like right there. So you have c bar of 200. Now, one thing I wanted to kind of look at on this is kind of go over something on this one curve right here. So this is the cost function that I graphed on my calculator to get that diagram. Now what's happening on this is the slope of the tangent line's changing, right? Okay, so what's happening on this is, which part would have a bigger rate of change, right here or right there?
The lower one.
Yes, because the tangent line's steeper. So what's happening on this problem is the rate of change is decreasing. And that's what you would want probably in a business, right? The more that you produce, the less the cost is going to be per item, say, okay? So that is a desirable cost function for a business for that reason, okay? So that's kind of typically the cost may be pretty high at the beginning, but then as you produce more and more items, then the cost per item is not as much. Does that make sense? Okay, it's just because of the way the slope is, and a marginal cost is a rate of change. It's a slope of a tangent line. Okay, so let's do an example of kind of what we were just talking about. So let's go ahead. This one is a cost of X food processors, and this is the cost function. So the first thing we're going to do is find the exact cost of the 21st food processor. So let's go ahead and do that. We've already done this a couple of times. Okay, so if you want to find the exact cost of the 21st, what do you do?
Plug in 21 for X.
C21 minus C20, right, okay. So let's do that one more time here. So I'm just going to do 2,000 plus 50 times 21, and then minus 0.5 times 21 to the second. You can go ahead and do that on your calculator if you want to. Then I'm going to do the C of 20, which is going to be 2,000 plus 50 times 20, and then minus 0.5 times 20 to the second. And you can do that, in 1 or 2 steps on the calculator. So I'm just going to do that on this calculator because I can see it better. And you can do this with me to kind of check my arithmetic if you want to. So I'm getting like 2,829.5 for the exact cost of the 20, or the total cost of the 21 items. And if I do the next one, I'm getting this 2,800. Okay, and then we could just subtract the 2. So that's going to give $29.50. Okay, like that. Okay, so that's the exact cost of producing that one food processor like that. Okay, that sounds kind of high to me, but I don't. What do I know about food processors? Okay, all right. Does that make sense what I'm doing? Okay, and everybody needs to make sure you wrap your mind around that is not the cost of that, because that would be an incredibly expensive food processor. That's all 21. That's all 20. So that's what you get then. Okay, so if you want to use the marginal cost to approximate, you want to go ahead and do the first derivative. Okay, so we're going to go ahead and do the derivative. Probably you can do this derivative in your head. Tell me what the derivative is.
50 plus
50
minus.
minus 1x. Remember what you're doing is you're doing the 0.5x squared. You're multiplying 0.5 times 2. And then x to the first, the power goes down 1, so that would be just 50 minus x. Okay? Now what are you going to do? C prime of what? Of 20. Yeah, don't get that backwards. It's got to be 1 below that. Okay? So you use this to approximate the answer that we just got. We got the exact answer. So what you would do is just do 50 minus 20, so you get $30. Okay? And again, these things are relatively close to one another. Okay? Yes.
Sorry, I didn't catch that. Why did you do 20 and not 21?
That's the thing you want to be clear about. If you go back and look at this theorem on here, it always works this way.
Okay.
So you use that derivative to approximate the exact cost of the next item. So if I want you to approximate 21, you do a derivative with 20, and so forth. Don't get it backwards. Okay? Now that's kind of what I was trying to show you on that graph with the x plus 1. That's where you want to try to wrap your head around. Okay, I'll let you guys go ahead and do this problem. After this, then we'll do a break as soon as you're done with this problem. So let's take a couple minutes. So the first one I got 140.20. Okay, that should be pretty, as long as you can do everything on your calculator okay. And let's see, what's your derivative? Okay, 2 times doubling 0.2 is 0.4, right? Now, what did you do to approximate? C prime of what? 24, right? Don't do it backwards, okay? Because I'm telling you, use it to approximate the next item. The next item from 24 is 25. So you should have done 150 minus 0.5 times 24. Be sure you don't get that backwards, okay? And were you pretty close? Let's see, this is 150 minus 0.4 times 24. So it is close, okay? $140.40. So you're only off by 20 cents, okay? All right, any questions about that? Okay, so that kind of gets us started a little bit on what you're doing with calculus and economics with marginal analysis. So let's go ahead and go through this problem then. And if you took finite math, you may have done some of this already, but not the calculus part. So what we have is you're given a price demand function. And what this is basically saying is the price varies depending on how many things you're producing, okay? So if you're producing and selling a lot of things, then maybe the price goes down. If you're maybe not selling as much and producing as much, then your price may go up a little bit. It varies. And then you're given a cost function, which is a linear function. Doesn't always have to be that way, but in this case, we're going to look at that. And what this is X is the number of high-density, high-definition televisions that you're selling, and your price is P dollars per television. That's the price per television, and then we have a total cost. So first thing we're going to do is we're going to take this, express the price P as a function of X. So let's go ahead and just write down this price demand function. And what we're going to do is we're going to solve it for P, and that's going to help us find what's called a sensible domain of this function, okay? There's going to be a certain production level where this thing is going to be reasonable, and then beyond that, it's not going to be reasonable anymore. So what we want to do is we want to go ahead and just solve this for P. So let's move this. I'm going to do this like this. You can add 30p to both sides, or just move it. I think at this level of class, when you solve equations, you just kind of want to move things and rearrange things just a little bit better. So I'm going to try to get P by itself. So the next thing I'm going to do is move the X over there. So that's going to give 30p equals 9,000 minus X, because I'm subtracting X from both sides. That's the reason the sign changes. And then the last thing that you need to do, if you're going to get P by itself, what do you need to do then? Divide by 30, right, okay. So we're going to go ahead and divide by 30. So we get an equation for the price as 9,000 minus X over 30. That's part of what we're going to look at this problem, is that is a price. So what's going to happen is, like for instance, if you produce 10 items, then you would do 9,000 minus 10 divided by 30, and that would give you the price per item. So that's changing. The next thing we want to do is find the domain of this function. So there's a couple of things that are important on this. Is the first thing is X has to be greater than or equal to 0, okay? Because X is how many things you're producing. So that's the number of items. You can't produce negative items. So what you're going to do is you're going to take this function right here, and let's just take it in this form. That's what X is. So what you're going to do is you're going to say 9,000 minus 30p is going to be greater than or equal to 0. So you've got to solve an inequality when you do this then to work this out then. And that's going to give you kind of an area that we're going to have on the price. And we also got to work with that price has to be greater than 0 also, okay? So I'm also going to have you do 9,000 minus X over 30 is greater than or equal to 0. That's the inequality ultimately we need to solve. So again, the price has to be positive, and so does the production. So does that make sense why X and P have to be greater than 0? Okay, it's nonsense. If not, price is positive, number of items is positive. Now let's go ahead and solve both of these inequalities. So if you do this, now there's more than one way to do this. I'm going to just choose to do it this way because I want to review something. So we would have negative 30p greater than or equal to negative 9,000 if I subtract 9,000 from both sides. Then I would have to divide by negative 30. And if you do that, you would have p, that would be 900 over 3, so that would be 30 like this. But you guys know from your background, if you're solving an inequality and you divide by a negative, you know what you have to remember to do. You have to flip it like that, right? So what you'd end up having is that price is going to have to be below $30, okay, like that. So if you do the 900 divided by 3, that's 300, sorry.
Couldn't you just move the 30 over and then you?
Yes, you can do it that way too. You can move the 30 and then leave the 900. That way you wouldn't have to flip the sign. I wanted to do it that way just to remind you of how you flip the sign. Okay, now let's solve this next one. So the way to solve this is get rid of the 30. How do you make the 30 go away? Multiply both sides by 30. Okay, if you got fractions, you know, we've dealt with that a little bit. You want to just multiply both sides by 30 like that. So this is kind of what you're after, is you have 9,000 minus x is greater than or equal to 0. Then what you can do on this is you can either move the 9,000 or you can move the x, or the x doesn't make any difference. I'm just going to write this as 9,000 is greater than or equal to x. Okay, so this is going to give you a domain, these two statements right here. And this is kind of the key, that what you're going to say your domain is. I'm going to write this just kind of underneath this. Your domain is going to be this. X has to be bigger than 0, and it has to be less than or equal to 9,000. So the production, and X represents the number of HD TVs you're selling. So what you get is that's your price function, but that's your domain. So when we look at this, we're only going to look at production from 0 televisions to 9,000 televisions. You didn't really have to do this inequality right here. This is kind of the main thing that you're doing, okay? But that price is also going to be less than or equal to 300 if you work out the details, okay? Does that make sense what I'm doing? Okay, the idea is X is the number of items you're producing. It must be positive. So that's the reason you set that positive. And you have to solve that for P first, so your inequality can be in terms of X. Okay, solve for P, then set this thing greater than or equal to 0. You guys with me on that? That's a big part of this problem, is being able to establish the boundaries between your production level from 0 to 9,000. Okay, now next thing we're going to do is we're going to do the marginal cost. So tell me what that means. Find the derivative of the cost, right? Okay. So the cost function I gave you is 150,000 plus 30x. Okay, so tell me what the derivative is. 30. Okay, now what that's going to mean on that, remember that's a rate of change. So that means the cost is fixed. It's never going to change. So no matter how many things you're producing, that cost is going to be $30. Okay, that's because that's a line. If you graph that, which we're going to graph in a little bit here, that's a line. And that 30 is the slope. Okay, all right, next thing we're going to do is find the revenue. Okay, so the revenue, you probably want to write this formula down. The revenue is basically this. It's the number of items that you sell times the price per item. Okay, and that needs to make sense. I mean, say your business is you're selling lemonade. You're a kid and you have a lemonade stand. Basically, let's say that every cup costs 50 cents. Well, if you sell 100 cups of lemonade, what's your revenue? 50 cents times 100 is your revenue, right? You're just multiplying how many things you sell times the cost of each item, right? Or the price of each item. So what you're going to have is the number of items is X. Okay, that's what that is. That's what that represents. And then the price, well, we have the price right here. So we solved this for P. What I've got highlighted in red here is your price. So that's going to be 9,000 minus x over 30. That's going to give you our revenue function. So what it is it's just x times p. Number of items you sell is x, p is the price, okay? Now what we want to do is write this as r of x for revenue, and then I'm going to go ahead and do a distributive property. So if I do a distributive property, I'd have 9,000x minus x squared all over 30, okay? And you can write the revenue that way, or you can also break it up. Typically what you'd like to do on this, you don't have to, it's just break the fraction up. So I'm going to do 9,000x over 30 minus x squared over 30, and then I want to write it this way. So if you do 9,000 divided by 30, that is 300, and I'm going to write this as minus 1/30 x squared. So that will be my revenue function like that. It's a good idea generally to just take it down to that level like there. Okay?
How come you squared added another x to?
Are you talking about right here?
Yeah.
Okay, because I'm doing a distributive property.
Oh, I got
So
it.
9,000x and then x times x is x squared.
Wouldn't it be 300x? Yeah, wouldn't it be 300x?
What's that?
Shouldn't it be 300?
Oh, I forgot my x, didn't I? Okay, that's not good. So we need to put that x in like that. So yeah, your revenue function is this, and we'll utilize this in just a minute. So what you're doing is you're doing x times the price. Okay, that's how you find revenue. Does that make sense? How many things you sell times the price of the items. The price is given as a function in this problem. Okay? All right, everybody with me there? Okay. Okay, how do you find marginal revenue? What does that tell you to do? Do a derivative, exactly. Okay? One of the reasons that you want to go ahead and get this down to this point right here is because now it's easy to do a derivative on. So when you do a derivative, what's the derivative of 300x? 300. Okay, how do you do the derivative of 1/30 x squared? You write the constant, right? And then you multiply it by derivative of x squared, which is 2x. So that's going to be 1/30 times 2x. Okay, like that. Okay, now you can reduce that 2 over 30 to 1 over 15. You're just dividing both of those by 2. So what you get is r prime, the marginal revenue, is 300 minus 1/15 x. Okay, so that would be the function that's giving you a rate of change of how the revenue is changing as x changes. Okay, x is the production level. Okay, everybody solid so far? Okay, see some blank stares. Anything I need to clarify?
1/30 times 15 over 30, right?
Right. Well, what I'm doing is when I'm doing the derivative here is I'm doing this part right here is 1/30 times 2x because I'm doing a derivative. Derivative of x squared is 2x, then I'm reducing 2/30. So if I'm reducing 2/30, I'm dividing top and bottom by 2. 2 divided by 2 is 1, 30 divided by 2 is 15. Okay, so I'm just reducing the fraction, okay? Okay, now let's go ahead and work these two things out. So if we're doing r prime of 3,000, we'll probably need to use our calculator on this. You want to take the revenue function, which is 300 minus 1/15 times 3,000. Okay, you can use your calculator on this if you want to. I'm going to punch this in like this. So 300. And a good way to do this is you can just do 3,000 divided by 15 if you want to. Okay, like that. And that will give a price of $100. And we're going to kind of write an interpretation on this too. Okay, so that's $100. Okay, then what we want to do is do r prime of $6,000, or sorry, 6,000 items, 6,000 TVs. So that's 300 minus 1/15 times 6,000. So I'll put that in. And you can just go 300 minus 6,000 divided by 15. I think you get a negative number on this one, which is okay. We'll need to talk about what that means. So that is negative 100 is what that is. Okay, and that is going to tell us something. Okay, so you get the revenue, you do x times p. the marginal revenue is doing the first derivative, and now we're going to evaluate these. Okay, one thing that you want to remember, when you do an interpretation, remember this is a slope. That right there is a rise over a run. And what the rise is the rise is talking about money. The run is talking about production, because that's you have an x-axis. So it's money related to production, like this. So here's the way that I would like you to write an interpretation. And you want to write this carefully in words. So let's do the interpretation of R prime of 3,000. Okay, what that means is this. It's going to, you want to say at a production level, I'll just abbreviate that PL for production level, at a production level of 3,000, I think these were what, HD TVs or something else. Yeah, HD TVs, of 3,000 HD TVs. Okay, now that's a positive number. Then what you're going to say is the revenue. You're telling me about the revenue, and you're telling me how it's changing. Now that's a positive, so you're saying the revenue is increasing by $100 per television. Okay, like not 1,000. I've got to put an extra zero in there. Okay, so that's the way I would want you to write that, is like that. When you're selling 3,000, the revenue is increasing to $100 per television, like that. Now that's going to change over time. Okay, now let's look at R prime of 6,000. You're going to write it in a very similar way. You're going to say at a production level of 6,000 HD TVs, what is the revenue doing? The revenue was negative. What does that tell you? It's decreasing. Okay, so we're going to say the revenue is decreasing by $100 per television, like that. So what's happening on that is your revenue is decreasing as you're producing more and more items, like that. That's the idea behind that. That's how that function models the problem. Okay, does that make sense to everybody? So be sure that you always talk about your production level, and you're always telling me whether it's increasing or decreasing, okay? And think of that as a slope. It's money per unit, okay, that you sell. All right, any questions so far? Okay, now we're going to graph, okay? So we're going to graph two things. You want to get your calculator out for this. So we're going to graph the cost function. So I need to write down what that cost function is here. Okay, so that is 150,000 plus 30x, okay, like that. And then we're also going to do the revenue function. So we're going to also do the revenue. Let me get the revenue function, which was 300x minus, and that was 1/30th x squared. Okay, now when you get into your first exam, this problem, you'll definitely see this whole type of problem on the exam, because this is putting a lot of things together. This is one of the things we'd want business majors to know from calculus and the idea of a derivative. So you want to do this on your calculator. I wouldn't expect you to do this any other way other than the calculator. So let's go ahead and let's put this in. So the cost function is 150,000 plus 3x, or is it 30x? 30x, thank you. Okay, 30x. Now what is that going to look like on your graphing calculator? That's a line, isn't it? What is the significance of 150,000? If it's y equals mx plus b, what does that 150,000 mean? It's a y-intercept, so you better make your y-axis go all the way up to 150,000. Those are important things you want to know. Now the revenue, you're going to go 300 times x, and then be sure when you put this 1/30th in that you have it in parentheses, because if you don't do that, it'll mess everything up. So just general rule of thumb, fractions need to go in parentheses, then you can put in the x squared. What is the graph of that going to look like? It's an x squared. It's a parabola going downward. There's a minus in front of that, like that. Now, the part of this problem sometimes students struggle with is how to get this window set up. Well, this right here is telling you how to set up the window for X. We figured that out in Part A. If you go all the way back to Part A of this problem, we figured out that the domain was between 0 and 9,000. I don't give that to you. You got to figure that out. So let's go ahead and get our window set up. So you're going to go 0 to 9,000. Oh, that's 90,000. Got too many zeros in there. So 0 to 9,000. A good scale would be probably, what, 1,000? Okay, that would be a logical way to do that. Now, the Y minimum, okay, Y is talking about certain values and everything on there. So what we're going to do is start with 0, and then you're just going to try to take an educated guess on it. You have to just play with this a little bit. I got pretty big numbers. One thing I know for sure is my y-intercept is 150,000. If my y-axis isn't going to 150,000, I'm not even going to see the whole line. So let's double that, and let's just take an educated guess, and let's try like 300,000, and then maybe scale that by 100,000. So what we want to do is you want to know what you're going to see. You're going to see a line starting at 150,000 sloping up, and then you're going to see a parabola. So if you type graph now, let's see if we need to adjust anything. There's your line. Okay, what do I need to do, obviously?
Adjust the Y.
Make the Y higher, okay? And you can kind of see how it's going. So let's just maybe try, let's go up to 900,000. That may be too big, but it doesn't matter. Let's just change that to 900,000. Okay, like that, and then let's see what we get. There's my line. Okay, that looks great. That's kind of what you're wanting to have on that, is something like that. So you have to know how to adjust those things. I'll put my graph and my window over here, so if you're still getting this put in, you can look at my, whoops, that's not what was supposed to happen. Okay, there's my window if you need to see that. So we got that put in. Okay, everybody with me? Okay. Okay, now when you draw a graph, and this is real important, there's certain things, if you're going to get full credit for a graph, you want to do things in a certain way here. So let's go ahead and, everything's messing up here. Yeah, here we go. Okay, what you want to do on this is we want to go ahead and draw your axis like this. Now all we care about is the positive x-axis, and we care about the positive y-axis. So you want to go ahead and sketch that. And then whatever you had on your graphing calculator, you want to label this like this. So in this problem, what are we selling? HDTV. So what you would want to say is that's X, and you would probably want to label and say this is the number of HDTVs. Now I want things represented. I mean, if you're a business person and you're, why did that thing erase itself? Sometimes this thing just totally messes up. So yeah, you want to definitely label that like that. Okay. OneNote is screwing up. Let me reboot it real quick. It does that every now and then. Okay, so we want to go ahead and get that put in. Then you want to get your scale done there. Okay, so if you look at the way we scaled this, we went all the way up to 9,000. So we can just go 1, 2, 3, 4, 5, 6, 7, 8, 9,000. Okay, and even if you just do that, that's okay, because I'm going to know that you're scaling that by 1,000 anyway, like that. Okay, what does the y-axis represent in this problem?
Revenue in dollars.
Okay, dollars. It's talking about something in dollars, so this is just kind of money in dollars. Okay, like that. And then we're going all the way up to 900,000, see? So let's just go like 1, 2, 3, 4, 5, 6, 7, 8, and then 900,000. You could also put 900K, because K standing for 1,000, like that. And that's good enough, okay? So you have dollars. All right. So what we're going to go ahead and do on this then is, if you're using your graphing calculator, what I'm looking for is just enough good points on this. So one thing that you can do on this is just use trace. Okay, so if you got your graph in, the first thing is you need to know that the y-intercept of this is 150,000. So this is like right there is your y-intercept right there. Okay, that's 100,000, that's 200,000, like that. Another good thing to do is trace at this end point right here. This graph comes to an end at 9,000, so you can trace. Now, one thing you got to do on this, on my calculator, it's telling me which function I'm tracing. It's tracing this. Now, you can either move your cursor key, or you could just type in 9,000 like this, and then that's going to give you 420, is that 420,000? I can't see very good. I think that's what that is. So 1, 2, 3, 4, just kind of approximate like that, okay? And then you might want to write a point that's 9,000, comma, 420,000, like that. I like to have you, when you're doing these problems, what I like you to have is just a few accurate points. Then you want to go ahead and just draw in, just connect those dots like that, and then label that. Be sure that you label that as your cost function, okay, like that, C of X. So that's what that is, okay? All right, so now what we're going to do is we're going to do the revenue, okay? Well, the revenue on here, and this is typically always going to be the same. If you don't sell anything, then you have zero revenue, right? You should always have a 0.00 on a revenue function. And then at 9,000, you can tell the same thing happens. Now, if you use trace and you got two graphs, when I type trace, see right now it's on the cost function. So if you toggle between the up, down, see now it's on the red graph. So now if I trace at 9,000, it's going to give me 0. So you got to make sure that when you're tracing the right thing. So then we just put a point there like that, okay? Now, one of the other things that I want to teach you how to do, we're going to learn how calculus is going to give this. The only other point that I think really makes that much difference is somewhere kind of in the middle. So like in the middle between 0 and 9,000, let's just trace it like 4,500. Okay, that might be the maximum. And again, see, I have to toggle onto the red one like that. So that's about 675,000. So you got 1, 2, 3, 4, 5, 6. So somewhere in here, okay, like right there is about 4,500. Then basically you can connect that like that, okay? So I want to just see like about all I got to see is 2 points on the line. On your quadratic, 3 points is good enough. And it doesn't have to be that maximum, but you just want to try to get a pretty good standard on that. So go ahead.
How do you change the Y1 to Y2?
Up and down. See, the way I do this is if you go down, it's now on the blue graph.
Gotcha.
If I toggle up, it's like this. And if you type trace, you can just toggle between the two functions to get those values. So you want to do that so you get a nice graph, and then you got it, okay? So that would be a good graph. It would have everything. We also want to label that as R of X. So when you're doing this on a test, I take points off if you don't label what your axes are, because you have to. Be sure you label which is revenue, which is cost, and then I'm looking for a logical scale, and then just, enough points so that it's reasonably accurate. Does that make sense? Okay, so now we're going to find what we're going to do on this is we're going to do two other things. We're going to find break-even points and show you where you have loss and profit. Okay, first of all, what happens if in your business right here the cost is above the revenue? What does that mean? If cost is more than the revenue you're bringing in, what's that tell you? You're losing money, okay? So the other thing I like you to do is just shade this area and then write a note to yourself that that is loss, okay? Where's another place where you're losing? Out at the tail, kind of right in here, right? So you also have some loss in there. So you're losing money there. You got a bummer going on there. Okay, where are you making money?
At the top of the revenue graph?
Yeah, exactly. Anytime revenue is, you're making more money than it costs to run your business, you're making money. So in there, you want to just shade that, kind of like that, and then label that as that's where you're making money, or gain or profit. You can just put profit there. So you're actually making money off of that. Okay, so what does break even mean, you think?
At the points where they intersect.
Right, the points where they intersect. Just means at this point right here, you're not losing money, but you're not making any either, right? No profit. no profit. So your break-even points are right here. So you might just put a dot there and label that as break-even. Okay, and right here, same thing. Want to do break-even like that. Okay, so what I'm going to go ahead and do on this is I'm going to show you how to get those with your calculator primarily. I'm not going to have you do this algebraically. So with your calculator, if I want you to find the break-even points, you might need to write these keystrokes down. So what you do, and I'll write them down as you go, you either know this or you might not, you go second, trace, these are the keystrokes, and then you go down to option 5, where it will say intersect. So your graphing calculator is going to find these values for you. So what you do is you just go down to option 5, and then you press enter. Okay, now what it's going to do is, let's find the break-even point on the left. So what you need to do is take your cursor and move it till you're fairly close to that point. You don't have to be like super close to it. That's probably good enough. The calculator needs to know which break-even point you're talking about. Then you press enter. Then a second cursor should come up on the other function. You press enter again. Then it's going to say guess. You just press enter again. And then when you do that, it'll start blinking on that break-even point. So that first break-even point is going to happen at 600, comma, does that say 168,000? I can't see very good. Yeah, 168,000. So what does that mean? What is the significance of 600?
That's the
600
amount of
TVs.
600 televisions, you're breaking even, okay? Once you get past 600, you're going to start profiting. Then you do the second break-even point. Just repeat the same thing. You got to start over again. Second, trace, option 5. Okay, now you just got to move your cursor like it's a little slow. My calculator is real slow because this has got a super high definition screen on here. So it's a little slow, and sometimes it runs, kind of gets, it doesn't work very good. So I'm going to do that. And you're going to know you're getting it right because it's going to blink on that correctly. So that means 7,500 televisions is your other break-even point where you're bringing in a revenue of $375,000 like that. Okay? So you want to make sure you know the significance of that. Between 600 and 7,500 televisions, that's where you're profiting. Okay, like that. So that's the idea. Does that make sense? Everybody okay? Okay. You guys may have a background for this if you've taken some business classes already or if you took finite math. Okay, next thing we're going to do is we're going to find the profit. Was everybody okay with what I did on the calculator? Because I expect you to do that on your calculator. You don't have to do that algebraically. The way you would do this algebraically, and I'm not going to go over this, but like on my math lab and stuff when you're doing homework, they're going to teach you that you just set those two things equal to each other and you solve that equation, and that's going to require the quadratic formula. Okay, you know, I think in the technological world, we're not going to worry so much about that. We want the graph anyway, so I want you to do that with your technology. Okay, right? Okay, now let's find the profit. So how does a business find its profit? Yeah, you got to take all your revenue. Okay, we've got the revenue, and then you're going to subtract your cost. So we're going to get a profit function. So when we do this, we usually say the profit function is capital P of X. Little p is usually price. Okay, the revenue, now we got to go back to what we graphed on the calculator. So the revenue is this thing. The cost is this thing. Those two things that I circle in blue are what you're going to have. So we want to write down the revenue is 300x minus 1/30 x squared. Then the cost is 150,000 plus 30x. Now you do want to algebraically simplify that by collecting like terms. So you want to do that, okay? So now the next thing I want to do, let's take the parentheses off. So you'd have 300x minus 1/30x squared minus 150,000. And what's that 30x going to become? Yeah, be careful about stuff like that. A lot of times students will kind of get a little careless and don't pay attention to signs. Now the only like terms I have are the x's. So let's write the answer to this profit function as let's write it kind of in descending order of exponents. Negative 130x squared, 300 minus 30 is plus 270x. Then we have minus 150,000 like that. Okay? So that would be the answer to your profit function right there. So it's revenue minus cost. All right? Okay, does that look good to everybody? Okay. Now let's put this in our calculator also, because I want to show you kind of what happens on this. Let's add a third graph, and I want to see if this makes sense to you, because you definitely want to make sense of the meaning of all these graphs. So the way you're going to put this in is negative 1/30th. You want to be sure you put that in parentheses, like that, and then plus 270x.
We got the x squared.
Oh, I forgot the x squared. Thank you. Okay, so we got to put in the x squared. Okay, then plus 270x, and you should have a parabola that comes out on this, 270x, and then minus 150,000. So you'll have a parabola opening downward like this. Okay, so I want to see if this makes any sense to you. I'm hoping it does. What is the value of the profit at a break-even point? What's your profit right there?
Yeah.
Look at the profit. Isn't that function value 0? Zero profit. Look at there. There's another break-even point. Zero profit. See there? So this value, that black graph right there, is giving you the value of profit as you're selling more and more items. Now, when we get in a little bit later next week, we'll start learning how to use calculus to figure out what that value is that makes that profit a max, and what the value is that makes the revenue a maximum. That's another basic calculus problem like that. So that would be your profit, how that looks. Does that make sense? Okay? It match up perfectly with those break-even points like that. It's a way to tell that you've got that right, which is a reasonable thing to do. Okay, how are you going to find the marginal profit? Now do the derivative. Okay? Okay, so we want to go ahead and do the derivative. So that's of the function I've got highlighted in yellow. That's negative 1/30th times 2x plus 270. So the marginal profit function is going to be negative 1/15x plus 270. You can write it that way, or you can also write it that way. It doesn't make any difference. Okay, so I'm just going to write my marginal profit like that. What I did is I reduced the 2/30ths. That's how I got the 1/15. So again, I'm writing the constant down, doing the derivative of x squared, and the derivative of x is the number in front. Okay? So we want to close this off by doing the marginal profit at 1,500 televisions. So we're going to do 270 minus 1/15 times 1,500. Okay, and I'll just do this on my calculator here. You can just do 270 minus 1,500 divided by 15. So that's going to be $170. And then the profit at 4,500, let's see what that is. That'll be 270 minus 115 times 4,500. So 4,500 over 15 is going to be negative $30. Okay, what does that tell you if you got negative $30? Now, it doesn't mean necessarily that we're losing money, because remember, this is a marginal profit, so it's telling you that that money is decreasing. That profit is decreasing at that point in time. So one of the things that I want to kind of show you on here, if you look at your graph on here, like if I was to trace at 4,500, and I got to make sure I get that black graph to come out. Let me show you what's happening, okay? Okay, right there. I want you to look at this. Isn't this past the point where the profit is maximized? So what you're going to find is once you get past that point there, profit's going down. It's decreasing. But before that maximum, what's the profit doing? Okay, you got positive values like that. Okay, so that's the idea. All right, so let's write kind of an interpretation on these things then too. So basically for the first one, we would say at a production level of 1,500 TVs, remember this is a slope, so we would say the profit is increasing at a rate of $170 per television, okay, like that. Okay, and then the next one we would say at a production level of 4,500 TVs, okay, what's the profit doing? It's decreasing, right? So we'd say the profit is decreasing at a rate, or you don't have to put the word rate because it's implied in this, so you say decreasing at a rate of $30 per television. Okay, so your profit is decreasing, is what you're still making profit, but your profit is beginning to decrease. Okay, all right, so that's the idea. What we'll end up looking at a little bit in the future next week is, okay, what maximizes the profit? What maximizes the revenue? And that's a calculus problem, okay? Okay, everybody with me on that? So that's a big problem that you'll see on your first exam. I mean, every single part of that, and that puts a lot of things we've learned together. That puts at least some of the calculus we've been doing into some sort of a context, okay? Which might help you a little bit. Okay, so here's, I just took this out of the book. Now this is more for you just to refer to. Like we talked about, you want to make sure you know what break-even points are on a graph. Where's the loss? Where's the profit? What does everything represent in that? So the last thing I want to look at is what we're talking about by average cost. And usually we represent average cost with a bar. So anytime you see C bar of X, that's talking about average cost. So it's not talking about a total cost of producing items, it's talking about the average, okay? And if you're doing R bar, that's going to be like a average revenue and so forth. And then P bar is going to be average profit and so forth. Okay, so I've given you the formulas. Really what you're doing on this is you're taking the function and you're dividing it by X. So you're doing an average. So remember, C of X is a total cost. And that's a grand total cost right there. And then X is the number of items that you're producing. So you're averaging this out. Okay, total cost per item. Okay, and then the marginal average cost is a derivative. So you write that as C bar prime. And then the average revenue is R of X over X, same way. Marginal average revenue is derivative, and then average profit is P of X over X, and marginal again means take a derivative. So when you're doing marginal, you're doing a rate of change, okay? So I'm going to do one illustration of this to kind of finish this section up then. Okay, so this one I've given a cost function. You're manufacturing drill bits in the petroleum industry, and you're estimating the daily cost in dollars. So this is a daily cost of producing X bits. So X is going to represent how many of the drill bits that you're producing, okay? So first of all, we want to do two things. We want to, first of all, if I do this, I want you to know what that means, okay? So like on a test, I'm not going to say necessarily find the average cost. I might just say find C bar of X. You've got to know what that means. So really all you do is you take the cost function that I give you and you divide it by X, okay? So you're just going to take 1,000 plus 25X minus 0.1X squared, and you're going to divide that by X, okay? Now you can leave it that way, but you don't want to leave it that way, because in the next problem, what are you going to do? You're going to do the derivative. If I'm looking for C bar prime of X, that's finding the marginal average cost. So you want to break this up. You want to say 1,000 over X plus 25X over X minus 0.1X squared over X like that. You definitely want to get that simplified. Okay, so I'm going to write that as C bar X. Okay, now before you differentiate, if you were going to differentiate 1,000 over X, what would you have to do to that X? You have to bring it to the top to make a negative exponent. So I'm going to have you go ahead and just write that like this. Okay, so we're going to write that first term as 1,000 x to the negative 1. Okay, the next term, what happens? The x's cross out, so that's 25. Next term, what happens? One of the x's cross out, so you're at 0.1x. So there's the algebra that's involved in that with simplification. So right there would be the best way to write that average cost function. Okay, all you got to do is divide by x to get an average function. Okay, and the bar is what tells you that. Okay, now what we're going to do on this is we're going to do the derivative of this to get that average, marginal average cost. Okay, so let's do that. Well, what you do is you do power rule. So you'd multiply the negative 1 times 1,000 to get negative 1,000. What's the exponent going to go to? Negative 2, right? So we got negative 2. What's the derivative of 25? 0. And how about the derivative of 0.1x? Okay, so there you go. Okay, and you can write it that way if you want to, or you can make that negative exponent positive. You don't have to. I'm okay if you wrote a answer like that. That's fine, but let's go ahead and just do one more step.
Why would it be negative 0.1x and would be just negative 0.1?
No, because I'm doing, hold on, where is my,
Yeah.
oh yeah, you're right, okay, sorry about that. Yeah, the derivative of something times x is the number in front. Okay, so I'm just going to write this as negative 1,000 over x squared minus 0.01 like that. So that would be your marginal average cost like that, okay? Okay, so let's define these two values and kind of talk about what they mean. So this first one, if you're doing C bar of 10, okay, you got 10 drill bits you're producing. So you're just going to plug that into what I've got in yellow here. Okay, let's just plug this into the cost function. So that's going to be 1,000, 10 to the negative 1, plus 25, minus 0.1 times 10 like that, okay? And you can type that in your calculator exactly like that if you want to, just in one step. Okay, so if I do that, I'm going to have 1,000 times 10 to the negative 1. 10 to the negative 1 is 1/10, so you can also put that in as, and you can write this like this if you want to. Let me do this again real quick. You can type in as 1,000 and then times 10. You can use that negative 1 power key, or you can do caret key, the exponent, negative 1 like that if you want to. And then we'd have plus 25. And then it would be minus 0.1 times 10. Okay, so that's going to give 124 is what you should get there. And that's a cost, so it's 124, and we'll talk about what that means. Okay, if you want to do the marginal average cost, you're going to take what I have highlighted in blue, which is negative 1,000 times 10 to the negative 2, and then minus 0.1. So you can just type that in like that if you want to. Okay, right? So I'm going to type that in as negative 1,000. And then times 10 raised to the negative 2. So I'll put that in like that, and then come out of the exponent and then put minus 0.1. So that's going to give about negative $10.10 like that. Okay, so that's what you should be getting when you do the calculation.
So you don't put it with in the fraction, negative 1,000 over x squared?
Oh, you can if you want to. It's up to you. You'll get the same answer. So you could do negative 1,000 slash 10 to the second minus 0.1, and it'll give you the same thing. Now, I think this right here was supposed to have it's got an extra 0 on it, it looks like that. Okay, everybody okay with what I'm doing? Okay. Let's talk about what these two things mean then. Okay, so I want to kind of finish that up, and just one other thing I want to do here. Okay, so let's talk about what C bar of 10 means. Okay, so basically what this means is, again, you always start this off the same way. You would say at a production level of 10 drill bits, I think is what we were producing, and it usually says per whatever. That's a daily thing, per day. Okay, then all we're going to say on that is the average cost is 124, okay? And then what we're doing on this is we're dividing by the number of items that we're doing there. That's not per drill bit, that's per day, like that. That's total average cost. Okay, and then the marginal cost, what that represents is this. Kind of the same thing. We'd say at a production level of, again, same thing, 10 drill bits per day. Okay, then what's happening, now what is that, since it's a negative 1010, remember that is a rate of change. What's that tell you? Decreasing. So then we're going to say the average cost is decreasing by $10.10 per day. Okay, like that. So it's kind of the same thing. Anytime you're talking about a marginal of something, you're talking about how it's increasing or decreasing, like that. That's the idea. Okay? Is that okay? Everybody understand what's going on?
So the first thing that you said is the average cost is really increasing by 124 per day?
You don't have to say that on that because it's not a rate. If you're doing C bar of X, you're not doing a rate. You're just telling me what that cost is. So that cost is $124 per day for those 10 items that you're producing. And the next one's a rate of change, so it is the average cost is going to be decreasing by 10 per day for those 10 things that you're producing. Okay? All right, that's how that goes. Then the last prop, yes, go ahead.
How did you type in the negative exponent?
Okay, like this. What you have to do on this, when I did this one, I did negative 1,000, like that, and then I did times 10, and then you just put like that's your exponent key. Your negative key is right here. So you got to put negative. Don't put a subtraction symbol in or it'll give you an error. So you got to put that in like that. Okay, you got your exponent key right there, and then your negative key there. Okay. Okay, let's go ahead and let's see what we need to do on this last one. It says use the results in part B to estimate the average cost per bit at a production level of 11 bits per day. Okay, so what we just did now is what we just did is we found that C bar prime of 10 was equal to negative 10.10 like this. So we're going to estimate the average cost per bit at a production level of 11 bits per day. Now remember, what we got into was we had this before. What you guys learned is you learned that, like, if you were doing the marginal cost approximates what? The exact cost of what? Okay, that's what we learned a little bit earlier in this section. Now we're talking about average, so it's no different. So this thing would approximate this. So really, C bar prime of 10 is also going to approximate the exact average cost per bit. So this is going to be the same thing as C bar of 11 with not a derivative. There shouldn't be a derivative there because this is given the exact average cost at the 11th bit. So it would go like that. So it's going to be exactly the same thing. Okay. So what you would find.
Wouldn't it be a 10?
10. Thank you. Yeah. Okay. Sorry about that. Okay. So that's 10 right there. All right. So let's go ahead and let's do this. This would be an approximation, but let's go ahead and let's work out C bar of 11 minus C bar of 10. Let's go ahead and do that and see if it's fairly close to that negative 1010. So let's take the average cost function, which is what I've got in yellow here. So I need to write that down here so I can see what I'm doing here. So I'm going to write this here. So C bar of X is, and that's 1,000 X negative 1 plus 25 minus 0.1X. So I'm going to go ahead and just approximate this like this. So let's do 1,000 times 11 to the negative 1 plus 25 minus 0.1 times 11. Okay, and see what that's going to give is the average cost of all 11 drill bits produced. Okay, did I forget a square? I don't think I have a square on the cost function, do I? No, because that's the marginal. The marginal's got the -2. I'm looking at this right here. I'm looking at the one that I highlighted in yellow. That's the average cost function right there. Okay, I'm not doing the derivative. We already did the derivative. We got -10, 10. Okay, and then over here we're going to do the same thing with 10. So we're going to do 1,000 times 10 to the -1 plus 25 minus 0.1 times 10, like that. Okay, now I'm just going to put this in my calculator. I want to make sure that you know how to do this. I'm going to do this first and record it, and then that second record it. So I've got 1,000 times 11 to the -1, and then plus 25 minus 0.1 times 11. Okay, so that's given 114.81 approximately. And then the next one, 1,000 times 10 to the -1, and then plus 25, and then minus 0.1 times 10 is going to give 124, like that. Okay, so if I subtract those two, I should be pretty close to the -10, 10. Let's see if that's indeed right. Okay, so let's see, 114.81. I got -$9.19. That's not too bad. Okay, so basically the idea is that is an estimate of the exact average cost, like I've shown. Okay, now that's the reason I put 11 in my problem, because I knew that I already did the marginal for 10. That's the idea. Okay, so that's perfect timing. So I got everything done on that today. We'll do the